E-Chemistry class, Fatima Convent High School, myself Dipali. Chapter 2, Acids, Bases and Salt. Let us move to the next topic of this chapter, that is salt. We all are familiar with the taste of salt and utility of salt in the day-to-day life and especially in our food recipes. Each and every recipe in the food has salt in it, and without salt, we do not like to eat food or taste food even. We even know what importance salt played in our national movement as the Dandi March was the movement towards breaking the salt law and to get justice against the unfair practices of British rule. Now let us see how the salt is important for us in science and how are the characteristics of this salt. So, in the previous section, we have seen the formation of salt during various reactions. Let us understand more about this preparation properties and uses. Family of salt. Write the chemical formula of salt given below. Potassium sulphate, that is that is K2SO4. Sodium sulphate Na2SO4. Calcium sulphate CaSO4. Magnesium sulphate MgSO4. Copper sulphate CuSO4. Sodium chloride NaCl. Sodium nitrate NaNO3. Sodium carbonate Na2CO3 and ammonium chloride NH4Cl. These are all salts, and salt have the same positive or negative radical are said to be family of salts. The example of salt family like NaCl, Na2SO4 and Na2CO3 are family of sodium salt. Same way NaCl, KCl, NH4Cl etc. are family of chloride salts. Family of salt means salt possessing same positive or negative radical. Sodium salts NaCl, Na2SO4, chloride salt NaCl, KCl, magnesium salts MgCl2, MgSO4. So these are different salts which we come across. Identify the acid and base from which the salt may be obtained. So you can say K2SO4 can be obtained from H2SO4 and KOH. Here H2SO4 and NaOH. Here H2SO4 and CaOH twice. Then H2SO4 and MgOH twice. Then H2SO4 and CuOH twice. HCl, NaOH. Then HNO3 and NaOH. H2CO3, NaOH. And HCl and NH4OH. These are the acids and bases which gives us the respective salts. We know that the salts are formed by neutralization reaction or reaction between acid and base. So, salts having same positive and negative ions are said to be belonging to same family. For example, NaCl and Na2SO4 belong to sodium family. Similarly, NaCl and KCl belong to chloride family. There are many more families like sulfate family, etc. Now let us see the pH of salt. Collection of following salt samples: sodium chloride, potassium nitrate, aluminium chloride, zinc sulphate, copper sulphate, sodium acetate, sodium carbonate and sodium hydrogen carbonate. Some other salts available can also be taken. Check their solubility in water. Use distilled water only. Check the action of these solutions on litmus and find the pH using the pH paper. Which of the salts are acidic or basic or neutral? Identify the acid or base used to form the salts. Report the observation in the table. Now the salts of strong acid and strong bases are neutral with pH 7. On the other hand, salts of strong acid and weak bases are acidic with pH less than 7, and salts of strong base and weak acids are basic in nature and pH is more than 7. So let us take the examples of these various salts and check their pH. We have sodium chloride, that is NaCl. It's soluble in water and pH is 7 as it is formed from HCl and NaOH. Both of them are equal in strength and they are so neutral as pH is 7. Next is potassium nitrate. KNO3, which is again soluble, pH is 7. It is formed by HNO3 and KOH and it is also neutral. Next we have aluminium chloride, Al, Cl3, which is soluble and the pH is less than 7. It is formed by HCl and AlOH thrice and is acidic in nature. Next is zinc sulphate, ZnSO4, soluble less than 7. It is formed by H2SO4 and ZnOH twice and is acidic in nature. Then we have copper sulphate, CuSO4, soluble less than 7. It is formed from H2SO4, CuOH twice and is acidic in nature. Then we have sodium acetate, which is soluble, pH is greater than 7 and it is formed from CH3COOH. COH and NaOH, which is basic in nature. Then sodium carbonate Na2CO3 is soluble less greater than 7 and is formed from H2CO3 and NaOH and is basic in nature. Then you have sodium hydrogen carbonate NaHCO3 soluble greater than 7 formed from H2CO3 and NaOH, which is basic in nature. So we can easily say that the salts are formed by the reaction between acid and base, and their acidity or basicity depends upon weakness and strength of the given acid or base from which they are formed. Now let us see chemicals made from common salt. By now you have learned that salt formed by combination of hydrochloric acid and sodium hydroxide solution is called as sodium chloride. This salt that you use in food you must have observed in the above activity is neutral salt. Seawater contains many salts dissolved in it. Sodium chloride is prepared from these salts. Deposits of solid salts are also found in several parts of the world. These large crystals are often brown due to impurities. This is called rock salt. Beds of rock salt are formed when sea of bygone ages dried up. Rock salt is mined from like coal. You must have heard about Mahatma Gandhi's Dandi March. Did you? Did you know that sodium chloride was such an important symbol in the struggle of our freedom? Yes, we know about the Dandi March. Now let us see the common salt, a raw material for many chemicals. The common salt thus obtained is an important raw material for various materials of daily use, such as sodium hydroxide, baking soda, washing soda, bleaching powder, and many more. Let us see how one substance is used for making all these different substances. Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride called brine, it decomposes to form sodium hydroxide. The process is called the chlor-alkali process because of the production of formed as chlor for chlorine and alkali for sodium hydroxide. The equation formed for this is 2NaCl plus 2H2O gives 2NaOH plus Cl2 plus H2. The chlorine gas is given off at the anode as seen in the figure and hydrogen gas at cathode. The sodium hydroxide solution is formed near the cathode. The three products obtained in this process are also very useful. You can see from the figure that in this setup the brine is entering from the inlet and brine containing NaOH is coming out from the outlet. There is an anode and cathode, an outlet for Cl2 and H2 gas, where H2 gas is later on used as fuels for making margarines, ammonia for fertilizers, etc. The NaOH, which is liberated in form of brine, is used for degreasing metals, soaps and detergents, paper and making artificial fibers. And here the Cl2 gas is used for water treatment, swimming pools, PVC, disinfectants, CFCs, that is chlorofluorocarbons and pesticides. So this is a very useful important chloralkali process. Next, let us see how bleaching powder is prepared. You have already come to know that chlorine is the product during electrolysis of aqueous sodium chloride brine. This chloride gas is used for manufacturing of bleaching powder. Bleaching powder is generally used for white color of the clothes or removing the dye color of the clothes. Bleaching powder is produced by the action of chlorine on dry slake lime, that is CaOH twice. Bleaching powder is represented as CaOCl2, though the actual composition is quite complex. So CaOH twice plus Cl2 gives CaOCl2 plus H2O. Now let us see the uses of bleaching powder. So the reaction and the equation for making bleaching powder is very simple. When calcium hydroxide or slake lime reacts with chlorine gas, it forms bleaching powder plus water. And the use of bleaching powder is for bleaching cotton and linen in textile industries, for bleaching wood pulp in paper factories, and for bleaching washed clothes in laundries, as an oxidizing agent in many chemical industries, and for making drinking water free from germs. Now let us see the next one, that is baking soda, which is frequently used in the kitchen by your mother for making the pakoras or various cakes and bakery items and even many more. Yes, that mouth-watering recipes need baking soda. Let us see how this is prepared. The baking soda is commonly used in the kitchen for making tasty crispy pakoras, etc. Sometimes it is added for faster cooking as well. The chemical name of compounds in sodium hydrogen carbonate, NaHCO3. It is produced using sodium chloride as one of the raw material. NaCl plus H2O plus CO2 plus NH3. That is when salt, water, carbon dioxide and ammonia reacts, it gives ammonium chloride and sodium hydrogen carbonate. Did you check the pH of sodium hydrogen carbonate? Yes. Can you correlate why it can be used to neutralize the acid? It is a mild non-corrosive basic salt. And the reaction that takes place when it is heated during cooking is 2NaHCO3 on heating gives Na2 CO3 plus H2O plus CO2, that is sodium carbonate, water and carbon dioxide. So sodium hydrogen carbonate has got various uses in household. For making baking powder, which is a mixture of baking soda, sodium hydrogen carbonate and a mild edible acid such as tartaric acid. When baking soda is heated or mixed in water, the following reaction takes place. NaHCO3 plus H plus ion from the water gives carbon dioxide plus water plus sodium salts of acid. Carbon dioxide produced during the reaction can cause bread or cake to rise, making them soft and spongy. Now, do you understand how your cake is so tasty and soft and how your bread is so soft? It is due to the action of baking soda, which produces carbon dioxide, and effervescence of the carbon dioxide causes pores in it and makes it spongy. Sodium hydrogen carbonate is also an ingredient in antacids. Being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. So that is the use of baking soda. Now let us see washing soda. Another chemical that can be obtained from sodium chloride is Na2CO3 10H2O, that is washing soda. You have seen above that sodium carbonate can be obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is a basic salt. So Na2CO3 plus 10H2O gives Na2CO3 10H2O. Here, what does 10H2O signify? Does it make Na2CO3 wet? We will address this question in the next section. Sodium carbonate and sodium hydrogen carbonate are useful for many chemical industrial processes as well. Use of washing soda. Sodium carbonate washing soda is used in glass, soap and paper industries. It is used in manufacturing of sodium compounds such as borax. Sodium carbonate can be used as a cleaning agent for domestic purposes. It is used for removing permanent hardness of water. Now let us see what does the water molecule which is attached to the washing soda molecule signifies. Are the crystals of salt really dry? Heat a few crystals of copper sulfate in a dry boiling tube. What is the color of copper sulfate after heating? It will almost turn into white. And do you notice water droplets in the boiling tube? Where does this come from? Yes, the copper sulfate crystal which seem to be dry contain water of crystallization. On heating the copper sulfate crystals, water molecules are removed from the crystal and appears in the boiling tube. Add 2 to 3 drops of water on the sample of copper sulfate obtained after heating. What you will observe is the blue color of copper sulfate disappears on adding 2-3 drops of water after heating it. And the chemical formula of hydrated copper sulfate is CuSO4 5H2O. So the water of crystalline indicates the fixed number of water molecule present in one formula unit of salt. Examples are CuSO4 for 5H2O, CaSO4 2H2O, FeSO4 7H2O and Na2CO3 10H2O. So, copper sulfate crystals which seems to be dry contain water of crystallization. When we heat the crystals, this water is removed and turns white. If you moisten the crystal again with water, you will find that the blue color of the crystals reappear. Water of crystallization is the fixed number of water molecules present in one formula unit of salts. 5 water molecules are present in the formula unit of copper sulfate. Chemical formulas for hydrated copper sulfate is CuSO4 5H2O. Now you would be able to answer the question whether the molecule of Na2CO3 10H2O is wet. On the other hand, which possesses water of crystallization is gypsum. It has 2 water molecules as water of crystallization. It has chemical formula CaSO4 2H2O. Let us look into the use of this salt. Plaster of Paris. On heating gypsum at 373 Kelvin, it loses water molecule and becomes calcium sulfate hemihydride, that is CaSO4 half H2O. This is called as plaster of Paris, which in common is known as POP. You must have seen or heard about this word frequently from the doctors or sometimes even the construction men. They use it for making ceilings and various decorative articles. Even the statues are made from plaster of Paris. And if you have met with an accident, the doctor uses plaster of Paris for supporting the fractured bone in the right position. Plaster of Paris is a white powder and on mixing with water it changes gypsum, once again giving a hard solid mass. CaSO4 half H2O plus 1 half H2O gives CaSO4 2H2O, that is gypsum. Note that only half a water molecule is shown to be attached as water of crystallization. How can we use half a water molecule? It is written in this form because two formula unit of CaSO4 shares one molecule of plaster of Paris. Plaster of Paris is used for making toys, material for decoration and for making surface smooth. Try to find out why is calcium sulfate hemihydride called plaster of Paris. It is called plaster of Paris because it was found in Paris and it was used for making various articles out of this special soil or clay which was obtained there. So we can see that the plaster of Paris, which is calcium sulfate hemihydride, is that very much clear? Now you will be easily able to answer the back exercise and questions given at the end of the chapter. Here we end the chapter with the uses of plaster of Paris. It is used in construction work, for making cast in the dentistry, in making idols, in making chalk for what writing on the blackboard. In laboratories, it is applied as plaster for making apparatus airtight. So this is what is plaster of Paris. Thank you for now.